All right, we got W2.5, the quickest possible review you'll probably get from me all year. So enjoy it while it lasts. All right, you got to do this for homework. Just to be clear on here, this is a little more of that Dr. Sarf, a little more of that let's get our graphs on point game. So how do you go about it? You see right down here, beneath each graph, there's a direct read and a slope box. So direct read is just asking you, what do you get? What does direct read give you from this particular graph? Well, here's a displacement time graph. So direct read, of course, gives you displacement and time. In particular, though, displacement. That's the one that's going to concern us. Slope gives you, think about it, don't memorize it, y label over x label, which is d over t, which is go look in your reference table, don't memorize it. You'll find the very first equation on PRT6. d over t is your velocity, or your average velocity. Okay, fine. So now that we know direct read gives us displacement, slope gives us the velocity, now we can say, okay, what is the graph actually doing? We call this the ones and twos. So the ones will be up here. What is the direct read doing? The direct read is just look at the line. What is it doing? Well, the direct read is the line is going up, that's increasing. If the line were going down, that's decreasing. So if you look here at A, that's an increasing direct read. At C, that's an increasing direct read also. It's just an uphill graph. If it's going down toward the axis, that would be decreasing. And if it's staying flat, that would be constant or remain the same. What is the slope doing? Well, the slope, you have to know, this is a constant slope, constant steepness. And in particular, it's not a zero constant, it's not a negative constant, it's a positive constant. So you can say slope is a positive constant. Now, just like you've done in math, we have a therefore. You probably haven't done that symbol. That symbol means therefore. Well, if we know that direct read represents displacement, and if we also know that direct read is increasing, well, what does that mean? What does that imply or necessarily entail? Well, if direct read is displacement and direct read is increasing, well, then you know, therefore, displacement is increasing. Of course. Same game with slope. Slope is your velocity. Slope is a positive constant. Therefore, velocity is a positive constant. The final step of this homework is to take your second comment, your slope comment, your positive constant velocity, and draw it as a graph. So you come over here and you put velocity on the y-axis, you put time on the x-axis, and you do exactly this line. Velocity is a positive constant. You may say, oh, why don't I plot the displacement? Well, it already is. It's over here. That's what you started with. So velocity is a positive constant. So you go to the positives. Here they are. And you make it constant. And there it is. Now, why did we do all this? Because this is how you connect the displacement time graph that looks like this to the velocity time graph that looks like this, because they both represent the same exact motion. So one graph is that diagonal, direct, one graph is that flat, but they both represent the same motion. And that's the point of what we've been doing. That's the point of Dr. Sarf. Different looking graphs can tell you either the same motion, and same looking graphs can be telling you different motion. You need a method to interpret them. Your intuition does not work well here. So you're going to find the paired graphs each time. You'll do the same thing for graph B, C, D, E, and F. And there's the bell.